Alright, what we're going to do is complete the square. Completing the square is essential to be able to do conics. We already saw it in a parabola. You're going to need to be able to do it for a hyperbola, an ellipse, and a circle. Absolutely essential. It's an Algebra 2 skill, so we're only going to concentrate right now on not getting this into a standard form of a parabola, but to simply how to complete the square in the basic technique. The first thing you want to do is you want to group everything together, all your variables together, all your like variables. This one only has one variable, so this is easy to see. It only has an x. We have an x squared and a 10x, and we have a subtraction in between it. If in the original problem, if it does not have an x on it, you need to put it on the other side of the equal sign like the 7 is. If you're given an equation, such as if this was x squared minus 10x minus 7, then you need to add 7 and bring it onto the other side of the equation. Completing the square is really only 2 steps. You have some intermediate math to figure some steps out to get some numbers, but other than that, it's only 2 steps. And it's not difficult. You should have seen this for the first time in Algebra 2. What we're going to do is, once you group all your things together, I want to call this group x, because you have 2 numbers, 2 terms that have x in it. One of them is squared, one of them is not. Right now, my leading coefficient is a 1, and in fact it's a positive 1. You'll see later on in other videos when this is not a positive 1, how to deal with it. But right now what we're going to look at is just simply take your middle term, your term that is not your leading coefficient, but the next coefficient, the one that has just the x. And you're going to divide it by 2. We're going to do 10 divided by 2. Basic math. This gives you 5. What you actually found is going to be your factor on the next step, when you have to factor the perfect square you're creating. Now you're going to take this 5, and you're going to square it, and that gives you 25. What we're going to do with this 25 right here is we're going to add it to both sides of the equation. We don't change the equation, but we're going to make it look different. This becomes x squared minus 10x plus 25 equals 7 plus 25. Now I know some of you guys can do the 7 plus 25 in your head, and it's fine. But get into the habit of just writing things down, so if you have to go back and refer to your notes, you're like, oh yeah, I have to take the original number and add the 25 to both sides. We really didn't change the equation, because if we take this 25 and subtract it, move it over to the other side, and then we have 25 minus 25, which is 0, meaning the equation is exactly the same. From here, all you need to do is the second step, which is factor right here, this quadratic. The whole reason why you complete the square is to create a perfect square, a perfect real factor. From here, give yourself a set of parentheses. Take your variable, the letter of your variable. In this case, it's an x. It could be a y, it could be a z, it could be a smiley face, it could be a heart, it could be anything you want. It's just whatever you have to represent a variable. Write it down here. This becomes x. Do not square it. Just take the representation, the x. Then you're going to take your sign and bring your sign down. You're using the sign in between your square term and your single term. In this case, it is minus. Then you're going to come over here, and the answer that you got when you took 10 divided by 2, this one right here, you're going to take that and put it right here. So this becomes x minus 5. And because this is a square, it's a quadratic, you're going to square it. Now, this is fully factored into x minus 5 squared, meaning that if you would multiply x minus 5 times x minus 5, you would get x squared minus 10x plus 25. And then from there, you just clean up the other side. 7 plus 25 is 32. So it's just basically 32. At this point, you are done completing the square. From here, we would use this information to be able to get the standard form of your conics.